fundamental sessions. In yesterday's session, we discussed about what is a data warehouse and what is the meaning of OLTP. One second. Aparam, can you please mute yourself?
Hello, Suresh.
Yeah, can you please mute yourself? Okay, I'm not asking for Suresh. Pawan.
Actually, I'm in this.
Suresh, where can I mute it?
In your headphone itself you can mute. Yep, no problem.
Yeah, actually your voice is breaking, Suresh.
Yeah, just okay. Let me check it. No problem. Is it okay now?
Yeah, it is. Yeah.
Yep. Thank you. Right. Yesterday we discussed about basic information. What is this data warehouse? Okay, what is the purpose of data warehouse? And what is the operational system? That basic thing only we discussed. And today we are going to start with data warehouse architecture, because we discussed yesterday simple definition of data warehouse. And okay, what are the PPTs I'm sharing you? Okay, once you confirm to the classes, I'm going to share these all the PPTs to you guys also. Up to this part we covered what is the difference between online transaction processing systems and online analytical processing systems also. Now we are going to start with the data warehouse architecture. Let me show you one architecture, then we'll come back to how we are going to implement that architecture also. Coming to this data warehouse architecture, this is a basic architecture for data warehouse, but depend upon project, the architecture will vary. Okay, just first let me explain you one basic architecture, then I will take some project architectures also. We will discuss some project architectures, how those are going to be vary from basic architecture, and because those project architectures also we are going to create based on basic architecture of our data warehouse only. In this data warehouse, if you observe, we have different layers is there. In this architecture, if you observe, we have different layers is there. One is data sources, second one is ETL software, third one is data store, and data store means data warehouse, and next one is data analysis and application tools, and end users will also access this one. But this piece is completely for reporting process. We are not going to bother about who are ETL developers, no need to worry about this piece. But this data store, sources whatever we have, that we need to know what kind of sources we have, how to extract the data. Next thing is we need to know about ETL process. Then we are going to know about how we are going to load the data into warehouse, what kind of indexes we are going to implement, what are the different type of dimension tables we are going to implement, fact tables, everything. First, let me explain what is this data source, or nothing but a front-end system. The same we can also call as a front-end. Here, data source is nothing but our upstream or our front-end system, which is going to provide data to data warehouse system. Every day we are going to fetch data from all the source systems and loading into data warehouse. Here these data sources are homogeneous or heterogeneous also. What is the meaning of this homogeneous and what is the meaning of heterogeneous? Here homogeneous in the sense all the sources are belongs to same database or same application. Sometimes we can see we are going to fetch, especially in a finance domains or healthcare domains, we can see most of our systems are into mainframe only. We are going to fetch the data from mainframe systems and we are going to load the data into warehouse. Sometimes we can see some data is going to maintain on fully into database systems. We are going to extract the data from those database systems and convert the ETL operations, applying the ETL operations. Finally, we are going to load the data into data warehouse. If all my source systems are same system, that we can simply call as homogeneous. But in this example, if you observe here, we have different systems there: product related data, marketing related data, HR related data, finance, accounting, ERP, like demographic, different kinds of data is there. But these different kinds of data is representing on different independent systems. These are not all same. Like, let me open one project architecture. How this is going to be there in a project. Just a minute. If you observe, this is one of the bank domain project. Okay, in this particular project, whatever we observe, these are called data source systems. In these sources, oh, 1 second, maybe I'm speaking okay with my mic is loud. Okay, little bit far. 1 second, just a minute. Let me change my position. Is it okay now, or still okay? Any issue? Yep. Okay. 1 second. Let me change. Okay, my mic position also. Then it will be good. 1 second, please. Now we are good, I think. Here, what we are going to have in this particular system is, if you observe in the source systems, in a source system we have multiple sources is there. Okay, these multiple sources in the sense we have, okay, Linux system is there. This is one of the banking domain project, okay, as I told you. In this Linux system, we have account opening front end. This is one of the application which is going to maintain all account opening process. And next one is, okay, that is okay, workflow transactional data. Every day, what are the transactions are happening in business, those transactional data is going to maintain on this transactional system, that is workflow. The workflow is also going to maintain in this Linux machine, and account opening is maintained on Linux. All the account opening data is also maintaining on Linux. And the next one is this is okay, CAMS flow, consumer account maintenance system is there. This consumer account maintenance system is also belongs to what kind of consumer accounts are opened by customers. Those data is maintained on completely on AIX, that is IBM AIX flavor of Unix. Okay, we are maintaining. And some systems are data, some data is maintained on, this is APS. APS means application processing system. This application processing system is completely maintained that bank call center data. Okay, to whom everyday bank people are calling and what kind of calls they are receiving, what kind of requests they are receiving, all the kind of data we are going to maintain in separate system, that is called APS. And one more system is there, that's called OH cards. This is completely going to maintain the data of all the health cards data and all the credit cards data, whatever is okay supported by our bank, because this bank is also offers some health cards as well, health plans, health insurance plans also they're going to support, as well as the same time they're also going to support some credit cards as well. This data is maintained on system Z here. System Z means it's a mainframe application. Every day we are going to connect with the mainframe and we are going to fetch the data from mainframe and we are going to load into ETL process and we are going to load into the warehouse process also, means warehouse database as well. Like this we have some other systems also. This is other, and this is some external application like SAP systems is there. From SAP R/3 system we are going to every day fetch the data and we are going to load the data into warehouse. And some data is also present. The last system whatever we have, this system is completely going to maintain about the daily transactions, about ATM transactions. Okay, this is nothing but last system. This is one is ATM transactions, and okay, import export data means the kind of international transfers. What are the customers are doing international transfers or mutual funds, and what kind of other systems like wealth management plans. These data is present on this system. These all the data whatever we have in these systems are maintained on system I. The loan data, okay, other transactional data is also maintaining on system I. Okay, these all are nothing but a our source systems, right? In this example project also, we have all the source systems are heterogeneous. If sometimes we can see all are reside on same database or same mainframe environment, then it will be homogeneous. That is about data sources, right? Next, in any project, normal, also whatever the data sources we have, those are going to maintain by some different front-end teams will be there. Those people are going to take care about the data, whatever they have in the system. If there is any issue or if there is any data issue or something, they need to rectify. In case today we receive some file from them by extraction process, but that file don't have the proper data, that file don't have proper date formats, that file don't have proper format, okay, they told that this is a comma separated file, but we received a space separated file, then we are going to send a mail notification to the front-end team saying that the file which we received today is not a comma separated file, but actually as per logic we need to get a comma separated file, or as per logic header record should be there, footer record should be there. This kind of information also we can send into front-end. Each and every application is going to be maintained by different teams. That is about the data sources. Next. Second one is we have here is a ETL layer. What is this ETL layer? What we are going to do with this ETL layer? Here ETL layer means, what is the meaning of ETL? ETL means extraction, transformation, loading. What is the meaning of extraction? Extraction is the process of retrieving data from homogeneous sources or heterogeneous sources into staging area or landing area. Okay, for these all the definitions I have materials is there, I'm going to send you. Okay, once you confirmed, I'm going to send all the materials. We can go to the definitions. If you want, you can write running or something. This extraction means it's the process of retrieving data from either homogeneous sources or heterogeneous sources into staging area or landing area. What is this staging area or what is this landing area? Let me show you in project. We'll compare everything with project. Here, if you observe in this particular project which I opened or which I am going to open now, this is one more project document. See, these are our mainframe data. This is called source systems. Mainframe, and HP Unix and some other application is out there. This is called landing zone. This is separate server. Landing area means the server where we install our data stage software. The Unix machine where we install our data stage server components in the landing area. Okay, we are going to have one folder. The folder name or a directory structure. One directory called landing area directory. Every day what are the files we are extracting from source system, those files will be moved into that landing directory structure. Once those files are arrived, we are going to do some basic validation. Then we are going to move the files from landing area to staging area. Then staging area to warehouse. Right? The same thing will be there in another project. This is one project architecture. Let me go for other architecture. This is other project. See here. This is sources. This is called landing. And this is staging. But you can see one more staging here. Is it a staging of our? No, it's a front-end staging. But because this is a high-level architecture, they show what the front-end people also do. Once, okay, they extract the data, we have separate staging is there because in this project, we are going to do CDC process here, but actually as per flow, then staging area, then warehouse, then mods, then reporting people will come to generate reports. In this flow, we are going to extract the data from these all the heterogeneous or homogeneous sources into our ETL server. From all the homogeneous or heterogeneous servers into our ETL server. That's called landing area. The server where we install our ETL software is called landing area. Right? And sometimes some projects we can see there is no separate landing area. We can maintain every data which is coming from separate source systems. We are going to maintain that data in a staging area itself. Maybe we can copy into staging area or landing area. Once you copy the data into landing area, once basic validations are performed by ETL developer by writing a scripting or by using some routines, then we are going to load the data into staging area. Right? What is the meaning of staging area? Yeah. The meaning of staging area. Staging area is nothing but our intermediate area. It's a database application where we are going to stage our tables data which is coming from my source system. Once all the data is ready in staging area, then we can do some kind of transformations and surrogate key creations, and finally we are going to load the data into warehouse also. Generally, staging area also and database system which is going to modeled by our DB team, and all our work tables, our active tables. Every day the data will come into staging area and the data will be loaded from staging area to warehouse. And we are also going to maintain a backup of staging tables also, depends on project. Some people will maintain 15 days archive of the data, and some people will maintain maximum 90 days of archival data also in staging database table with archive version of the same tables as well. Right? That is called staging area. Means the data which is there in front end are source system to extract every day. Okay. See here, to extract the data from multiple different applications in source, we have multiple tools we are using. If Linux system, to get the files from that Linux system, we are going to write some Unix scripting or Linux scripting. The script will execute every day and it will pick up the files what are there in front end. It will put in landing box. If it is okay AX system, because some AX files are okay, will come in a format of message queuing. That's what we are also install the message queue. We are going to fetch the data from message queue through message queue to our ETL process. And next one is through mainframe, to get the data from mainframe, because the mainframe data is available in ASCII format, but DataStage is a tool which is going to support ASCII format data. This ASCII format data, whatever we want to fetch, it's not going to directly support the ASCII to ASCII conversion. We are using some third-party server that's called Connect Direct Gateway Server. Here in this Connect Direct Gateway Server, we have some Unix scripting is there. The data sets, whatever we are getting from mainframe, that we are going to convert. Okay, the GDG or the GDG format, whatever we are capturing the data sets are from mainframe or files, whatever we are getting from mainframe, we are going to convert that into normal text files, and we are going to process through this Connect Gateway Server. And if it is okay, external applications, because this is a some web-based applications is there, some SAP data is there. To get the data from SAP system, we have a SAP systems is there, and WebTrans is also going to install some plugins. And because these two are databases, we are going to use the ODBC connector to fetch data from these database systems into our ETL layer or staging layer, right? To get the data from these all the heterogeneous sources, we are using heterogeneous technologies to fetch and to load the data into ETL layer. That's called landing area, right? Assume that today we fetch all the related files from all the related data from all the tables, and we are loading into this ETL layer. Once the data is ready here, ETL layer, what we are going to do in landing area? For every project, there will be some basic validations will be there. What are those basic validations? What are the files we receive today? Are those files are having correct date formats, correct dates, correct records, correct number of records? Sometimes when a file we receive, the file they are going to tell you that in a footer, this file is having some 1 lakh records, but actually the file is having only 75,000 records is there. The footer, whatever they mention, is not going to match with the actual number of records. That's what, okay, we need to check and confirm by writing some Unix scripting. We can do basic validation automatically every day. Once a file is received from my upstream tool, my ETL landing area, our Unix script will start executing, and it will check whether the file which is arrived today is a correct file or a bad file. If that is a bad file, we are not going to load from here to here and here to here. Okay, not. We are going to stop that file here itself, and we are going to send a automatic notification activity or mail notification to this source system saying that so and so file we received today, that is not a correct file, we are not processing. Could you please send a exact file whatever we have? 1 second. No, when we run that, there is no separate team or something. When we run our batch processing, generally when it comes to your project is going to production, or while doing the cycle running, we are going to use some third-party scheduling tool like Control-M or AutoSys or TWS or some kind of those third-party tools is there generally, which are used to process our DataStage jobs along with the scripts also. No, there is no separate team will be there. If you are a developer of DataStage, you also should have knowledge on Unix scripting. That's what we are also going to discuss some scripts in the middle of our classes. Okay, how to write those scripts and how to call those scripts in DataStage, what kind of scripts we are going to write also. Because some automation we want to do. Automation in the sense, every day when the files are received on our landing box, we want to validate those files. After validation of the file, if the file is appears as a good file, then corresponding data stage job will run. If the file is not a good file, then we need to send a mail to the front end saying that so and so file we received. These records are bad records. Could you please send again the same file or recheck the file with the business? Okay. Any other questions? I will discuss you. Okay. In coming classes, we'll also discuss how to write in scripting as well. Okay, fine. I think, okay, there is no question. If you have any question, please ping me, then we can discuss. Right. Then the validations are done. We are going to create some data stage jobs. Those jobs will fetch the data from this ETL layer to this staging area. We know what is the staging area means. A staging area is nothing but some database environment. See here. This is completely when we develop a project, this is on DB2. On the same DB2 database, some part of schema is allocated to staging database, some part is allocated to warehouse, some part is allocated to marts also. In the same database, 3 different environments are reside. Okay, one is staging area, one is warehouse, one is marts. But for these 3 different environments, we have 3 different schemas because table names also not be same. Okay, naming conventions will vary. Okay, this schema will be different, this schema will be different, this schema will be different. When we are trying to fetch the data from staging table, select star from the particular schema name dot table name. When we are trying to fetch the data from the warehouse table, select star from the schema name dot table name. The schemas will be different, table names also will be different. Here this staging area is going to convert all these files whatever we receive into tables, and now the data is ready in staging area. Next, what we are going to do in staging area? While loading the data from staging area to warehouse, we are going to do so many transformations. What kind of transformation we are going to do? Let me show you. Just a minute. If you have any confusions or any questions, please ask me. See here. These are the operations wherever we use a term ETL, there we are going to develop the data stage jobs. This is called sources. Okay. This is nothing but staging area. This is intermediate processing. Intermediate processing, we are going to have some third-party tools, scripting or everything. Once we extract the data from source to this, okay, to get the data into staging area also, we are going to write some ETL. That's called, okay, mapping and defaulting and formatting. Once the formatted data is ready in staging area, we are also going to do again data stage jobs. Some jobs is there. Those jobs will convert the data and ready to load the data into warehouse. This is a warehouse system. Before loading the data into this BAR to warehouse, we are going to create a surrogate key. Here surrogate key is a word which is going to act as a primary key in warehouse, and some kind of referential integrity mapping we are going to do, and normal ETL mapping also we are going to do. Finally, we are going to load the data into warehouse. This is front end, this is warehouse. In between, we are going to use ETL in different phases. This is actually same for what the project architecture I am showing you. Once the data is ready in staging area, we need to start loading staging data from staging area to warehouse. To load the data from staging area to warehouse, we have separate jobs are designed. Those jobs are going to load data into data warehouse system. Okay. Those jobs are simply going to load the data into data warehouse system. Here, once the data is ready in warehouse, what kind of data we are going to maintain in warehouse? What is the way we are going to maintain data in warehouse means? Here, what is this data warehouse? And I am telling that we are going to load the data from landing area to staging area and staging area to warehouse. This process is called transformation. We are going to apply all the transformation logics. Concatenation of 2 strings, finding the highest values, finding the aggregation values, removing the duplicates on the data, trying to convert the inconsistent data into consistent format. Okay, these are all the kind of transformation we are going to do. Once transformations we did while extracting the data from landing area to staging area and staging area to warehouse, finally we are going to load the data into data warehouse by using dimension tables and fact tables. Means What are the different type of tables available in warehouse means? There are different type of tables available. Some are dimensional tables, some are called fact tables. Okay, I will tell you what is this dimension table and fact table. These are the different type of tables will be there, and the data which is there in warehouse also will be stored in structured wise. Each and every dimension table which is there, that particular dimension table, whatever we have, these particular dimension tables are going to be maintained on subject area. A subject area means a small business unit. It's going to maintain the data like that in warehouse. Loading the data from staging area to warehouse is nothing but a loading. That's called ETL. E means extract from source systems into ETL layer. Once extraction is done, then moving the data from ETL layer to staging area by doing some operations is called transformation. Once the transformations are completed, then we will load the data into the warehouse by creating primary key in all the dimension tables. Right? Once the data warehouse is ready, we are also going to load the data into marts. What is the meaning of this data mart means? A data mart is a subject-oriented subset of data warehouse. This is nothing but a small piece of data warehouse. Okay, this is all about data warehouse basic architecture. Once the marts are going to be loaded, then our reporting people will come and they are going to access the data which is there in marts to generate different kind of requirements reports which is there in business. Right? This is about the data warehouse architecture. In project, just let me open again in normal basics. See here, once we load the data into data warehouse system from source to ETL to warehouse, then different reports, okay, we are going to generate for analyst. There will be different reports for managers, for executives, for operational staff, and for customers and suppliers, or for end users. They will generate different kind of report by using different reporting tools, whatever is possible to generate reports. Okay, that is about data warehousing architecture. Any questions on this? Fine. Okay, if there is no question, then okay, we will go for next topic. To implement this data warehouse architecture, okay, means to implement a data warehouse for any business, there are multiple different type of approaches is there to implement that one. What are the approaches we are going to implement and how we are going to implement those approaches? Just okay, we are going to discuss in basics part of this data warehousing fundamentals. What are the different approaches? When we are discussing as per our course content about the project, we will discuss about how to implement those approaches. Just a minute. To implement a data warehouse, generally there are different approaches. Top approach and second one is bottom. So what is this top down approach? What is this bottom up approach? What we are going to do approach and what we are going to do in bottom up approach. Here top down approach is an approach we are going to our to create the data marts left warehouse. And approach is completely reverse to that one. Sometimes in some okay, sometimes we can approach as well. Right? Now, how to implement this top-down approach? Just oh, okay. One second. Maybe I move my headphone for 1 second. Today it's giving a little bit issues. 1 second. Is it okay now or still having issue?
No, it is okay. I mean, could you please explain top down again?
Oh, yeah, I'm explaining okay very detailedly. What's an approach? How we are going to proceed for this approach? we are implementing any approach, okay, we have source is there. Okay, just let me check it. It's very speed internet. What is happening? One second. Let me check. Okay, now check it. If any issues are there, we will check it. Okay, this is not internet issue, I think. Okay, because mine is having very speed one. Because in previous batches I have nearly 18 to 19 people also there in a batch. Okay, there is no issue, but maybe this time is it internet issue or something. I'll check with my internet network provider also. We'll try to rectify in case any issue with that. I'm thinking that this is with the headphone or something. Let me check it. Here, whatever we have and what is the process we are going to have in this one is, when it comes to this particular top-down approach, in top-down approach data warehousing implementation, what we are going to do is we simply going to implement top-down approach with different sources is there. Source 1, source 2, source 3 is there. Okay, these sources whatever we have in top-down approach, which is having a heterogeneous sources or homogeneous sources, whatever it may be. Okay, the sources may be heterogeneous or may be homogeneous. Still it's breaking. Anyone having any issue? Okay, just a minute. Right. The sources whatever we have here, these sources, okay, whatever we are implementing this mathematics, these sources we simply going to call as heterogeneous sources or homogeneous sources. One may be having customer data, one may be having order data, one may be having manufacturer data. We are going to load these data from these all the sources into staging area. Once the data is ready in staging area, in top-down approach, what we are going to do is we are going to create some kind of data mart structure. Because here, what is this data mart? What it is going to do in this data mart means, in data mart, we simply going to create which is belongs to one subject area. For example, I have a customer subject area in my warehouse. I'm going to create a one customer data mart structure in this one. In diagram, I'm showing this is separate layer, but actually while implementing a warehouse, we don't have this is separate layer. This is also included in staging area. Means once the data is arrived from heterogeneous sources, we are going to create different kinds of data marts. Once we create different kinds of data marts there, then we will load the data into data warehouse. Just let me show you. Okay, once we load the data into data warehouse, we will also create finally digital marts. Okay, then loading data in staging area, creating the marts, then loading the data into warehouse. Okay. What's the problem? Not sure what's the problem here. Just a second. It's breaking off because in the morning too, I'm teaching the classes, but now it's breaking. Yep, check it. Okay, 1 or 2 minutes. We can stop it. Also, issue in this time. Just a minute. It's okay. It's very speed. Okay, about speed, it's not a problem. Maybe this time it's not working or something because in the just before your class there are 18 people are attending in the batch. Okay, that batch. Okay, we are having no issues even because of more people also there. but in this time maybe network or system or something. I'll check it. Okay, I'll try to rectify before tomorrow our class. Okay, check it 2 minutes. If still having issue, we'll stop the class. Right. Here we have different sources is there. In these sources, whatever we are implementing, in these all the sources we are going to have multiple extractions we are going to do, and we are finally loading the data into warehouse to marts also. The approach which we are implementing to create the marts in top down is, once we load the data into warehouse, we are creating the marts. This approach simply we are going to call as a top to down approach. Just let me show you the project architecture which we created. Down or bottom up. If you observe in the system, we have here is the n number of sources, right? ETL layer, ETL to staging, staging to warehouse, warehouse to marts, right? This is the approach which is we implemented to create this kind of data warehouse architecture. This approach, which approach we follow here is top to down approach. The approach which we follow here is the top to down approach, which is we are implementing in warehouses. Still it's breaking, Srini? If it is breaking, we can stop. Okay, we don't want to waste your time without understanding. Okay. I need to check it. Okay, why it's breaking sometimes? Is this network issue or something? I'll check it. Okay, I'll write here before tomorrow. Sure. Right. Whatever the data we are having in this one, this approach is nothing but simply a top-down approach. This is simply we are going to implement. The next type of approach which we are going to use, implement this one. Are you data stage developer is going to take care about these approaches? No. These top-down approach or bottom-up approach are the approaches which we are going to follow by data warehousing architects. Whoever is creating a data warehouse architecture for that particular project, they will follow this approach. But generally, as a developer, we should also understand how our project is, architecture is created. Is it follow top-down approach or bottom-up approach, right? Now, just we discuss what is this top-down approach, but how to implement this top-down approach we can discuss in projects. Because, we need to know project level knowledge, then we can discuss how to implement a top-down approach process in our project also when we are discussing about project classes. Now, let me discuss how we will bottom. This is quite reverse to the top-down approach. When you go for top-down approach, once we implemented a warehouse, we are creating the marts. These marts, whatever we have in top-down approach, are completely depend upon data warehouse. These are completely going to be depend upon this data warehouse. That is the reason the marts which are created in this top-down approach are complete, dependent data marts. The marts which are there, these are the dependent data marts. These are going to have with dependency on enterprise data warehouse. Next. Second type of approach which we have is the bottom-up approach. What is the meaning of this bottom-up approach? In the case of bottom-up approach also, we are going to get the data from heterogeneous sources, loading the data into staging area. Once the data is loaded into staging area, we are also going to create the different kind of marts. Once we create the structure, see, this is not actual physical mart. This is going to create a structure in staging area database itself. Then we are going to physically create the data marts on our database. Then finally we are going to load the data into warehouse. In a bottom-up approach case, we are going to create the data marts in parallel with while loading the data into warehouse, or before loading the data into warehouse, we are going to create the data marts. This type of approach also we can see in some projects to implement data warehouse. Right. In these two approaches, which approach is the best? We have top-down approach is there. We have bottom-up approach is there. As per some benefits, we can tell that some cases we can tell that top-down is best. Some cases we can tell that bottom-up approach is best. But more cases, we can simply tell that a bottom-up approach is a good one with comparison of top-down, because the cost-wise and performance-wise, it will be good, right? What is going to happen in top-down approach? In top-down approach, we are going to have more planning and design is initially needed while implementing any data warehouse, right? While implementing any data warehousing for any project, we are going to have more planning and more design is needed for that one. But when it comes to the bottom-up approach, we can plan initially without waiting for global infrastructure. Okay, no need to wait for global means structure. We can step by step we can do. Source to staging, staging to logical marts to loading the data into physical marts data and warehouse. Step by step approach we can follow in bottom up approach process, but in top down that is not possible. We need to have a proper plan. And in top down approach, because once we load the data into warehouse, we are going to create different kinds of marts. While creating the marts from the data warehouse data, we need people help from different individual departments. That's what we are going to call as a, this top down approach involves people from different work groups and department. But this is a step by step process, no need of any other teams involvement or other departments involvement in creation of this one. Next, in top down approach, what are the data marts we are creating? Those data marts we are going to create after creating the data warehouse. That's called data marts may be create or build later from global data warehouse. Okay, once we create the data warehouse, then only we are going to create the data marts. And the data, whatever we have in the bottom up approach, we can build before or in parallel with the global data warehouse. Okay, when it comes to the bottom up approach, we can build before warehouse creation or parallelly we can load. We can design a data stage job. One link is going to load the data into warehouse table. One link is going to load the data into mart table also, right? That's also one difference. But data consistency wise and okay, accuracy wise, top down approach will provide good data because we are taking the help of the different individual department people. But when it comes to bottom up approach, the data redundancy will be there. Sometimes same data may be okay reside on data marts of 2 or more data marts also. There may be chance of getting some inconsistency between data marts as well. Okay, but data wise, if you see top down approach is automatically going to provide because we are taking the help of different individual departments and individual teams also. But when it comes to bottom up approach, we are not going to follow any teams or something. We directly load the data into warehouse and warehouse to marts also. If parallelly, in that kind of situation, we may get some redundancy or inconsistency for that one. And in case of top down approach, there is a high cost and lengthy process and time consuming process. But bottom up approach is less cost of hardware and other resource. Okay, no need of much cost also, no need of greater planning. Okay, we are going to have step by step process also and faster payback. Based on these two approaches, which is the best one means actually apart from data, cost wise and process wise, bottom up approach is best. For getting the good data, we always need to try to look into while creating the tables in warehouse and marts. Are we getting any redundancy? How to eliminate the redundancy? Okay, how to process the redundancy? Okay, if it is acceptable redundancy, how to process the data? This acceptable redundancy in the warehouse. So all the things we also need to focus while implementing bottom up approach. These are the two approaches is there. We can see okay in different projects, different approaches. What are the project we are going to discuss in coming session? In that project, we are going to discuss how to implement top down or bottom up approach. This is about the data warehousing implementation approaches and data warehouse architecture. Any questions here? Right. To implement a data warehouse, we have okay any one of the approaches. Okay, once we implement a data warehouse, we are going to load the data. Means we created empty data tables in warehouse. We will load the data into those dimension tables and fact tables. Now, to create the warehouse tables, what tables need to be created? What are the primary keys is there? What are the foreign keys is there? Okay, how we will know means while we are trying to understand the business of the data warehouse, okay, what we are working with clients, okay, based on the client and based on the process they are following up, we are going to get some kind of modeling process from our data modeling teams. What is this data model? What is the use of this data model? Here, a data model is nothing but an abstraction of real world system, simply a kind of blueprint. Whatever the existing business is there, that existing business blueprint, okay, they are going to create in table structure and what is the proposal system also, right? That simply we can call as definition of data model. What is the meaning of data model means? A data model is an abstraction of some aspects of a real world system. It's completely going to maintain a blueprint of the real world system. Why a data model is required? While implementing a data warehouse, do we need every project is okay, need a model? Yes. While implementing any data warehousing project for especially for data warehousing and data mining process, we need to have proper model. If we don't have proper model, we are going to get some wrong results into the all the tables, and we are going to load some wrong data into all those tables also. If we have proper model, it will help to visualize the business. Means it's easy to understand the business because a model will give you a diagrammatical format about the business. If you're trying to understand the business requirement of BRD, it's not so easy to understand because it's going to completely having a kind of high level business information. But when we see this modeling document, we can understand what are the tables will be there in warehouse, which table is dependent upon which table, what are the primary keys, what are the foreign keys, those kind of information we can easily visualize about the business process. And model will act as a communicator between the developers who are working as in the ETL process to the business, because by seeing the diagrammatics we can understand what are the tables are required, which tables are dependent on which tables, and what are the primary key and foreign key, because when we pass to the primary key and foreign key columns, we need to know what is the primary key, where in which table we need to have primary key, those things also. That's called model will act as a communicator. And model will help elicit and document the requirements. What are the requirements are means what details need to implement this particular warehouse. Those we are going to document. That's the purpose of modeling. Model also will help and elicit document the requirements. And model is a process which will reduce the cost of change, because the existing legacy technology whatever we have, existing passive data warehouse whatever we have, that we are going to try to convert that into active data warehouse by using these ETL tools, data stage, Informatica, like that, right? While converting passive to active warehouse, if we have proper model, we can reduce the cost of change. If there is no proper model, we are not able to understand the time taken process, and everything will exceed the limits. And while implementing any data warehouse without any model, we will not be able to implement proper data warehouse whatever we are expecting into outputs. Right? This is a simple definition for data mart. In next session, we are going to discuss about what are the major steps in data mart, what are the levels of model. Tomorrow, we are going to discuss these data modeling process and how we are going to create the modeling also. Just let me show you some sample set of model document whatever we are going to have in our projects. See, this is the one of the modeling document for one of the projects. This is in one of the project. We are having this modeling document and track tables and what kind of process we are going to follow to load the data into these all the tables and columns, which is the primary key, which is the foreign key. How to implement normalization process. So all the things we are going to discuss in modeling sessions. Once the modeling is done, we will go for ETL basics. Questions here in today's session? If there is no question, then we'll meet tomorrow and we'll discuss same time. In the meantime, I'll also check my with my network people, is there any issue in the network or something. I don't want to interrupt the same voice breaking or something in tomorrow's session also. I'll we get with a good network, we can discuss more hours also tomorrow. If you have any questions or something, you can ask me now. Fine, and if there is no question, then we can meet tomorrow. Thanks for joining. Sorry.